this stuff because it's been a while since I took physics too.
It's hard, isn't it?
See, my problem is I don't have a problem with understanding. The problem I have is like actually like I'll get the wrong answer because I forget like to add a negative sign somewhere or something like that.
Oh yeah,
Something
just the
stupid.
small stuff. Yeah.
Yeah.
Yeah,
Thankfully, partial
it's always
credit's
something.
nice.
What?
Partial credit's nice though for that, but it's still like they'll nickel
Yeah.
and dime you, you know. Especially sig figs. I could never like keep track of sig figs.
Oh yeah, that's another one I would do is units. I would forget to put down the unit.
Wild, somebody, and Seth have entered.
Welcome, Seth. Whoever somebody is, welcome as well.
I believe somebody is a freshman.
Welcome, freshman somebody.
Let me look real quick. Megan Dobos.
Oh, thank you. Welcome, Megan.
I think she
Thank
has
you.
a
I'll join in a
brother-
minute. I'm making dinner, so.
Okay.
Okay. Let me check something.
Is her brother Cameron?
I don't know Cameron's last
That's a
name.
good question.
Yeah, I don't know. I don't know Cameron's last name.
Also, I'm on the phone because my internet gave out after talking about my internet going out.
Poor Joey.
Sounds like voodoo to me.
Hello?
But yes, she is a freshman. I just checked. When Joey installed the freshman, she came into.
Gotcha. Sam, join. We need you.
Well, asking him to join here isn't gonna help anything.
Oh, I sent him a DM.
Well, we can just summon him. Hey, Justin.
That's not Sam.
No, it's not. It's not Sam.
That's also
That's not Sam either.
Yeah, tough scenes.
Kicking him till it's Sam.
Yeah, good idea. I will start by kicking Seth.
Hey,
Alright, we'll get started in like a couple more minutes.
So you decided not to go with Comic Sans, huh?
I couldn't take it.
Yeah.
I tried,
Yeah.
but then I was like, this one looks so much better.
I think Serpent uses Comic Sans for all his presentations.
For all of them?
I think so.
Oh my gosh. I don't know why, but his
I
last
tried-
name like just sounds scary.
Because it's one letter away from T.
Yeah.
Well, or from Serpent.
Sam had to clean the pool, so he'll be in like 15 minutes. But that's okay. We can get started with that.
Oh boy.
Sam's in the pool.
He'll probably fall in while he's cleaning it, but yeah, he's cleaning his pool.
Oh, he's cleaning the pool.
Yes.
Again?
Again. Just like yesterday.
Have you guys ever seen the show Hoarders?
Yes.
No.
Like one episode.
There was this one guy with like a really nasty pool in his hoarded backyard. There were like dead animals in it and stuff. It was
That
disgusting.
sounds just like my coworker Nick. Things keep dying in his pool. Every fourth thing that goes into his pool dies. This is why I don't go to his house. Like, if you go in the pool, you have a pretty high chance.
Well, that's probably because he's a sim and someone keeps deleting the ladder.
Oh, like in a
Just
video
them.
game?
Yeah, The Sims, the original Sims.
Oh, okay. Oh, and you just can't get out, so they just sit there and drown after like however many hours.
Yes.
Very nice.
Yeah.
Very cool. That's a nice feature. All right.
Yeah.
Yeah. Yeah. He has some pretty crazy stories. Like well, there was the one time he was delivering a test set that we were making for Northrop Grumman. I wasn't like working there at the time, but anyways, he went to avail himself of the facilities, and he proceeded to flush the toilet. And you know that face that you make when the water begins to rise? Well, the water didn't stop rising, and so he went to go for the tank to try to stop it, and it was too late. So it started to overflow, and he's like, and there's no plunger, so he's like, "Well, we're going in," and he shoved his arm right in and started plunging. It's terrible.
Yeah, who was this?
I'm not gonna say. It's just my coworker.
Is it Nick?
Yeah, Churchill.
I don't know.
Oh,
I don't. You mentioned a coworker named Nick.
Yeah, Nick Churchill. He was around before, way before you were around. Couple semesters before. But I don't know. He loves telling stories. So stories like that, he's very good at telling them, and they're always very humorous.
Hey, is anyone else getting a 300 millisecond ping?
No.
I don't know.
My ping keeps jumping.
Aren't you out in like the boonies of Norwalk?
I'm on cable.
Oh. Okay.
Yeah, it's fluctuating from like 30 to like 800.
Jeez, that's rough. All right. Well, we can probably get started. I think everybody who's gonna come is gonna be here. Thank you all for coming. To the freshmen, welcome. It's good to have you here. Hopefully you'll keep on coming and find these lectures and events that we keep doing at ACM informative. Sam will be on later to talk more about our long-term project that we currently have going on, which is our ACM website. And we've been working on that for, I don't know, probably a couple months now. We started it this past summer. So the groundwork was laid, and so now we have a lot of different ideas of where we can take the project, and there's a lot of different levels of things to do if people are interested in learning stuff about web dev. And we're doing all of the parts of it. It's a totally custom website. So we have a backend where you can mess around with SQL and databases and learn about that. We have the front end and we have the back end that, Sam is a very good mentor for this because he has developed an entire website for Marks where he developed the front and the back end and the database. And so he has a pretty good idea of how the development process should work. He's got us set up really well on GitHub. There's a whole approval process where when you go to make changes, your changes have to be approved by 2 of your peers through peer reviews before they can be merged into the development server, and then you can see how the website, the changes that you made reflect on the website on the development branch. And then every 2 weeks we push to production. And today is the day that we're going to push to production later on after the talk and after he shows off the website a little bit. So he'll be in about 10 minutes, but we'll go over that once the just the talk has finished. Today we were going to go over a pretty basic overview of Python. Basically just been working on this continuously since the announcement went out like 2 days ago, to get this presentation ready. I made a little sample program that you guys will be able to download off of GitHub later on if you want to mess around with it. But really, this is hey, this is Python. Here are some of the things about it that you need to know. Here's some example code where you can go ahead and start playing around with it, and it's a good way. And I think playing around with it is one of the best ways to learn, because in all honesty, I don't have a ton of experience with Python. I've used some at hackathons, but it's not the language I'm most comfortable with, but it's pretty easy. And so just over the last couple days, I was able to learn a lot more than I even already knew. I messed around with a library called tkinter, which allows you to make graphical user interfaces. So I made a little app that I'll show you later, and you can download and play with later. So getting into what exactly Python is, it's a third-level programming language. And if you think of the hierarchy of languages, if you think about your computer and how it's got electrical signals going on the inside, right? Everything's transmitted in ones and zeros, right? That's the machine code, right? Okay, and then one step above that, there's a one-to-one correlation with assembly code, right? So you have a string of binary bits, ones and zeros, and you can associate a word such as add with just a certain string of ones and zeros. So 1111 could be represented by the word add, and that's assembly language. And then one step above that, you can have what we know as, you know, third level, high level programming languages, where you can issue commands such as print, right? And then that will get translated into assembly code and then down into machine code, and that's what the computer runs. So Python was developed to be very user friendly. So it's kind of even like above a third level language, where it's incredibly easy for humans to read. It was designed for that purpose by Guido van Rossum about 20 years ago. He started working on it for a project that he was doing at the company he was working for, and afterwards he just decided to release it as an open source thing that people could use, even though open source wasn't really a term that they used at the time. That came on a little bit later. So, and it really gained a little bit of a following after that, and people started working on it and adding to it, and they still have been to this day. And he recently stepped down as the head man, the guy in charge, and what's going to happen with the language is a committee will take over and decide, and you know, the direction that the language will take in the future. So the cool thing about Python is you can use it for scripting, so just writing short programs that do things, or you can use it like Java if you've taken 5010 as an object-oriented programming language that has classes, and you can use it that way. It's an interpreted language, which I found really interesting as opposed to a compiled language, which we'll get into later on. I found that really interesting. I think I found a good way to explain the difference between an interpreted and a compiled language. And it's named after the Monty Python comedian group, actually. So that's also interesting.
Welcome.
Hey, welcome.
Hello,
Hey, who's that?
Esteban.
Hey, Esteban, welcome to the lecture.
Nice to be here.
So, a couple of reasons why it's popular. I already mentioned a couple of them. It's easy to learn because it's very similar to English. It's easy to nail down the syntax to figure out what you want to do. Easy to read once you have it all typed out, relatively. It's got a lot of external libraries, so people have written a lot of Python code to do different things, and you can just take their code and use it in your own code to do different things. So for example, for one of the hackathon projects, my part of the project was I utilized an API that somebody else had written that got sports statistics, and so you could give it an input, say the Cleveland Browns, and it would and say like a game date or something like that, and it would return you the score of, you know, that they had on that date and who won and lost. So that's the Browns lost. So that is an example of using some code that other people have written that you can use in your own code. It's portable, which means that it is able to run on different platforms. It's able to run well on Linux, on Windows, on Mac OS, and that has a little bit to do with how it is interpreted, but we'll get into that later as well. It's also got a huge community that just writes these libraries and code snippets that you can go out online, and a lot of programming in Python when you first get started is just copy and pasting and messing around. So there's a lot of good resources online that have like code already written out that you can go and steal and mess around yourself. GUI programming is easy. You can literally make a window in 2 lines. It's great.
Hey, Danae, can you mute your mic?
Thank you, Kyle.
Sure, that's fine.
Thanks, Danae. So, and there's a lot more reasons why people love Python, but that's just a couple. So, I just wanted to show some of the main control structures that we have for programming languages and what they look like in Python. It's incredibly simple. For an if statement, for the conditional statement, you just say if, you have the parentheses, and you've got this colon at the end, and then you indent and put your statements here that you want executed. So, for example, if I had a variable I, or count, and I set it equal to 0, and in here the condition was when count is equal to 0, if that condition is true, it'll execute this block of code. Say it's print this word or whatever, and that'll output it to the console. If it's false, say if count is actually 2, then it'll come down here and it'll execute this branch of code. So it's there's no parentheses like other programming, or there's no curly braces like other programming languages. Everything is indented. So you have to be careful with how you manage your whitespace because it actually cares. In other languages, they're whitespace blind, which means you could write your entire program on one line and the compiler will not care. It'll just read it all in. But in Python, whitespace is very important, so you have to make sure that you're indenting properly, that if you are indenting with tab, make sure that you do that, and the people who are going to be modifying the code with you know that you're not entering, say, 4 spaces, because that's important. So that's the if statement. You've got your while expression, real simple. Again, you just have the colon at the end, and there's no parentheses. Same thing with the for loop. So, and these slides will be available afterwards so that people can go through them, and if they need help while they're, working on different projects, they can reference these, contact us in the Discord, and we'll be willing to help. So, here's just a very basic. This is just an example of variables and assigning variables in Python. So, one of the differences between Python and other languages is you use the pound symbol to represent comments, sections of code that are not going to be run by they're not going to be run. Other languages you use forward slashes or backslashes, but Python uses pound. Another interesting thing about Python is you don't have to really worry about variable types, because normally you would have to, for say Java, you would have to specify it and say this variable value 1, so this location that I'm going to store something, it's going to store something of type integer, so 6, right? Well, in Python, it has what's called dynamic variables, and so you don't have to assign it a type. It just knows, oh, you're putting an integer into this location. Okay, cool. Or I'm putting a string, and if you're not sure what a string is, it's just a sentence, basically, and you're storing it at this location. So you don't have to worry about data types, which can get confusing if you don't know what you did, but there are ways to remedy that, like descriptive variable names and comments as well. So this is an example of storing 2 integers into 2 different variables, adding them together, storing them in another variable, and then just outputting the result. And it's incredibly similar to English. It doesn't get much more simple than that. And that'll just output the result to the console. This is an example of a while loop. You just have the condition that you want, and it's going to loop so long as the variable I is less than 10. So it starts at 0, it'll loop through here. On the last iteration, it'll print out the number 9, it'll increment I to 10, it'll see, okay, I contains the number 10, which is not less than 10, and so we'll break out of the loop and it'll be done. So you will output 0 to 10, or 0 to 9. So it's very human readable, very easy. The hardest thing to pick up, I think, is the white space. You just got to make sure you don't mess up the white space. This is an example of casting in Python and if statements. So say I have an integer and I store it into a variable called myCounter. I can, if I need this value as a string that I can output to the console or manipulate in some way, then I can just simply cast it by surrounding it with parentheses and putting str at the front and storing it into another variable, which it'll see, oh, you're trying to store a string in here. And then you can, this is an example of an if statement where you're just looking to see, this is, if you haven't seen strings before, I'm sure most of you who are in here have, but strings are denoted by double quotes. So now you, instead of saying, instead of looking to see if it's an integer, because if you removed the double quotes, you would be comparing integers. You'd be trying to compare integers. But now it'll see, it'll compare. It'll say, okay, does my string contain 0? And then you've got the commas, or you've got the colon at the end to denote I'm going to the next line. This is my then statement. This is what the equivalent is in Java, and there's a lot more just string value. Like, there's just a lot of extra stuff going on here that Python kind of tries to strip away. And then for loops, all that's happening here is your variable I. Basically what this is saying is, in order from 1 to 10, each time we finish executing the loop, place the next integer into the container I, and then just print out I. So it's very human readable. So the next thing I wanted to get into was, how exactly does Python execute? And this was the thing that I found really interesting about Python as compared to normal programming languages. Now, normal programming languages like Java, no, not Java, but like C++, for example, the way they work, or C, is you write your C code, and that is represented by this block here, okay? And then it is, when you go to run it, there's a piece of program that goes, called the compiler, and it will take that code that you've written and it'll essentially translate it into what's known as assembly language. Okay, and this assembly language has a one-to-one correlation, as I was talking about, between itself and machine code. And machine code is what is run on the hardware. It's just the ones and the zeros that travel along the data buses of our computers, right? So Python doesn't work this way. This is essentially just taking, and I've got, say, you can compare it to somebody who's transcribing something from one language to another. You've got your C code over here, and then I've got my translator over here who turns it into this other language, which is easier for the hardware to read. And then you go one step further, and you have another translator who translates this down into machine code. Okay. And then that's able to be run by the hardware. So it's essentially an interpreter that translates stuff from what we can read to what the computer can read. Okay. Now, the way that Python works is there is another step in between. Okay. We'll get to this slide in a minute. But say when I want to do something very simple like print hello world, right? This is my Python code, okay? When I run this, it will be translated by an interpreter into what's known as Python bytecode, okay? Which is less human readable, but you know, you can still kind of get the gist of what's going on. So, but the hardware still can't understand this. So what has to happen is we have an intermediary, basically. This is going to be the input for what's known as the Python virtual machine. Now, the Python virtual machine is essentially a program that is written in C, and when you run your program, the Python virtual machine will be compiled into assembly language and then run as machine code. This virtual machine acts very similar to I like to think of it as a function generator, where you give it an input and it'll give you an output. Okay, so if you imagine this as the compiled Java virtual machine, okay, this is what's running on the hardware. Think of this guy, the function machine from math, right, as the virtual machine, where you give it an input, and the input is the Python bytecode. Okay, now the virtual machine can understand this code, and it knows how to execute it and turn it into something, and it knows how to execute it, and it knows how to give you an output. So you'll take your Python bytecode, it gets run by the Python virtual machine, and it just gives you your output. You don't have to worry about what's going on here, how it's interacting with hardware, anything. Just, you think of the Python virtual machine, right? It gets compiled down into machine code, right? And once it's running, it takes an input, which is the Python bytecode, and it gives you an output, which could be, for example, right here, for our Hello World example, our output is the output to the console. Okay? So, does that make sense to everybody? I hope it makes sense. I found that really interesting.
That makes sense to me, yeah.
Okay.
Yeah, I understand.
Yeah, another thing to note is in Python, when you do like for loops and stuff, when you start doing looping, every time you loop back through, it interprets the lines of code.
Oh, really?
Yeah, so that can be a huge performance hit, on top of Python already being a huge performance hit.
Right. Because Python is such a high-level language, it requires so much interpretation and I mean, it takes a lot to go from, compiling your Python virtual machine down into machine code and then running your Python code through this. It takes a lot of time because there's a lot of extra steps. Whereas if you just had a C program, it would just be compiled right down into assembly language and then run on the hardware. So this is a much faster process than all of this that's going on. But it allows us to make a much more human readable and understandable programming language, which is good for different applications. You wouldn't necessarily use Python for the same type of applications as you would for C. For C, you want very fast applications, things that can do things quickly, right? Whereas for Python, you're probably, a lot of it's used for like hackathon projects, for example. We use it for our hackathon projects where we don't always care about how fast our program runs. We just need to botch something together in order to deliver a product, right? So that's kind of how Python executes compared to a programming language, a compiled language. This is called an interpreted language, whereas C is compiled. Another thing to note is because Python runs this way, when you write your program, you can just feed the virtual machine code as it's running, for example. So, as an example, actually, I can pull up this command line here. Now, the virtual machine is already compiled and running in the background right now. And so if I do something like 3 plus 3, it's going to give me an output 6. So with C, you would have to wait for the program to compile that you just created. So it would have to get turned into assembly code and then run. Whereas with Python, well, the Python virtual machine's already been, it's already been compiled into machine code. And so you can just continuously give it input and it will give you an output. Whereas C, you can't do that. So I can also do things, I can assign variables like x equals 3, y equals 4, and I can do x plus y, and it gives me 7. And that's because it's running live, and I'm giving it an input and it's giving me an output. So that's a pretty cool thing about Python. So now,
I had
is
a
there
question.
any questions? Yeah, go ahead.
So for Python, does this mean that it's running it's translating the code that you wrote into a readable code for the computer as you're programming?
Correct.
As you're typing it? Okay.
Yes. When I'm doing it from here, yeah. When I'm
So
doing
that
it from
means
the
that
command
can
line here.
somewhat edit the program on the fly, while with C you can't.
With C, you can't really edit the program on the fly. You would have to be, the way that you have to write C is, you'd have to be in an IDE like this one. You write your code, you have to stop the program from running, and then you have to hit run, and it recompiles the entire thing. So you can't change it on the fly. But with Python, you can.
Okay.
Yeah.
I have a question too.
Okay.
I'm sorry.
go
Go
first.
ahead.
Go ahead, Danae.
Okay. Like, how does it do? Like, is there like a reason why it's running as you're coding?
Is there a reason why it's running while you're coding?
Like, like we were just currently discussing. Like, why is it that for some languages like Java or C, like we just mentioned, like you have to stop running in order for you to edit your code, but with Python you could just edit it while it's running. So why is that?
So Java actually does something very similar to this. It also has a virtual machine. So I misspoke earlier when I said Java ran similar to this structure here. Java, yes, Java has a virtual machine and it runs very similar to this. The reason, okay, is there a reason? I guess my answer is this is just the way that they built the language. Because you have already compiled this machine code, you've already compiled the Java virtual machine. Okay, this machine code is running on your hardware. Okay, and it's sitting there waiting for input. And so when you go and you enter, say, print hello world, and it converts this into bytecode.
Josh,
Yeah, go ahead.
you might have to repeat that. You cut out there for a whole decent amount of time.
Oh, sorry.
I thought I heard him.
Oh, maybe it was just me.
I heard him too.
It was
Yeah,
you.
fine.
It was you, idiot.
Sorry.
Yikes.
Because this has already been compiled, because the Python virtual machine has already been compiled and is running on the CPU, it's waiting for input. And you can think of it, I guess. I just find it easier to think of it as a machine that's sitting there waiting for you to give input. So I don't think of it as ones and zeros anymore. I just think of it as this device that I have compiled into machine code that's running and it's waiting for me to give it input. Because of that, I'm just able to pass it this bytecode and it can run it and give me an output. Whereas with C, when you write the code, there's nothing waiting there to run it. The code has to be translated for you from your C code, for example, into assembly, and then it can be directly run on the hardware. There's nothing running on the CPU. There's no program. There's no function generator. There's no machine there. There's no virtual machine that can run the code. The C code is running. It's being assembled down into machine code, and it's being run directly on the hard drive on your hardware. And so because of that, when you make a change here, it has to be interpreted. It has to be turned into these other languages here, so that the computer can understand. So the previous process has to be stopped. It has to be reinterpreted, and then it has to be run again.
A
I hope
question.
that makes sense. Go ahead.
Because you can change it on the fly, would you want to use a higher level language like Python for something that you don't want to have any to or little downtime?
Would you want to use Python for something that you didn't want to have much downtime on? Most of the time, the way that you phrase the question makes me think of like industrial applications, like Python being used in industrial applications, because in an industrial setting you don't want your systems to stay up for a long period of time, and you want to minimize downtime. Python isn't used a ton in industrial settings, is my understanding. That is a good question, and I don't really have a good answer for you though.
Okay.
Well, I think that problem is kind of solved by version control systems, like for instance GitHub.
Mm-hmm.
So when you're minimizing downtime, the biggest thing that you need to do is just basically schedule it.
Right. And like we have with the website, you have a development branch where you test everything first to make sure it's working properly before you deploy it to production. So that is that's typically how, at least things with like websites, and systems for, like, I worked at a manufacturing plant as well, and we had a very similar setup where you have a development environment, you program and you test in the development environment, and once you're sure that your program works properly, then you deploy it to production. That way you're minimizing downtime. You would never There are instances where companies actually go and they will be live modifying production equipment, causing like slowdowns and shutdowns. Like, I know a guy who works for Rockwell, and he's a technician who takes phone calls from people who need help. They can't solve their own problems, or they don't understand the software and they're trying to make changes. And some of these guys are like live modifying production equipment. You do not do that. You're supposed to have a development environment where you test stuff and change stuff first, and then you push it to production. That way, downtime is minimized. So I hope that helps, if that makes sense.
Yeah, that makes sense.
Okay. Any other questions? That was a good question, actually.
Yeah, my question, but it was more of a thought experiment than anything. Why would you want to have an interpreted language over a compiled language?
Why would you want to have an interpreted language over a compiled language?
Oh, I got a good one.
Okay.
So, when you use a calculator, do you enter in your commands one at a time, or do you have pre-written every single command, and then you run all of your calculations at once?
If it's a graphing calculator, you can technically do both.
Yeah.
Yeah.
But sometimes there's a time to use one and a time to use the other.
Yeah.
Python allows for you to do the kind of one thing at a time with the interpreter. And that kind of flexibility allows you to do certain things.
Because Python...
I was also going...
Go ahead.
Sorry. All right. I was also going to say that platform independence is a big thing for him too.
Right. Because the Python virtual machine can be compiled down onto different machines, the Python language itself doesn't have to change very much. It works well on Linux and Windows and all of those other things. It's totally hardware independent, as far as you're concerned. I think that makes sense. Any other questions? Comments?
Joey, also with your example of a calculator, if Python is written that way, then doesn't that also make it very easy to debug? So like if you have a really long program, but you're doing it step by step, you can figure out very easily where the issue is, right?
Yeah.
Okay.
That's a good use case. The fact that you can walk through it, it's kind of like, it's like a lot of debuggers for stuff, but the language itself kind of has a built-in debugger in the fact that it's running literally one line at a time, exactly how you type it,
Right.
which is kind of cool.
Yeah, to kind of piggyback off of that, for those of you who don't know, I have an old TI 99 computer, and it runs a basic dialect, and it's also interpreted. Part of the reason they did that then was because interpreters were smaller than compilers. I'm not sure if that's still the case, but they didn't need to have massive hardware to do it. But in any case, it'll run everything you write up until the point it stops working. So it can be kind of frustrating with that sort of thing because you type in each line individually. But luckily, we don't have to do that anymore.
Right.
But yeah, I think the function machine analogy works well in this scenario.
Yeah, I think so. It helped me understand it. Okay. Are there any more questions? If not, I'm gonna jump into the little example program that I made. Alright. So, this is an IDE, Integrated Development Environment, that I downloaded to work with Python. It's called PyCharm, and I've been liking it so far. So, this little program that I have is just composed of 2 files. I'm not going to spend a ton of time going into all the little details about what the code does, because that is boring, but I'll give you an overview of what it does. Now, tkinter is a library that allows you to make windows. Allows you to make graphical user interfaces. And so I had an idea for essentially a computer science and engineering quotes program that would... Here, I'll just run it and I'll show you first. Don't break. There we go. Alright. So, these are all just individual buttons, and I just put pictures on them of different people. And so in the background, I stored a bunch of different quotes from each of them, and so when you click on each of the windows, it outputs a quote that they've said in the past to the console. So, stuff about soccer, let's go, Dr. Thomas. I remember he said this is way cool in class. The more foot, more go, less foot, less go analogy. All of Professor Nolan's famous quotes.
What's some Kang ones?
Oh.
Oh. Okay.
And then it just starts looping around again. The Stonks boy. I was gonna make this guy spit out Joey quotes. I just didn't get around to it because I figured the bald, but
Yeah.
So, Dr. Thomas and his pay no attention to that professor behind the curtain. You need more comments than code. Dr. Hobbs, the Steelers stink. If you don't know, he loves the Steelers, and I like the Browns. So, oh yeah, and Luke's I don't know anything about the 2010 levy when he was misquoted by LC.
That's not a misquote. It was I didn't say that at all.
So, anyways, so that's just a simple program that I made in relatively few lines of code. Like it's just this here, which is setting up the buttons and the pictures, and just a couple lines here. I could even have not. I could have not even used all of these functions. I could have just made this a single function, I think, and just called it multiple times, but for each of the different buttons. But essentially, all you got is it's just very sloppily put together. But you've got an array that contains all of the quotes. It's a string array, and then so I just go through and put all the different quotes that I want in each of the arrays. And then up here, I have some integer variables because it's 0 based. So, for example, for Dr. Kang's quotes, I put that there are 2 quotes rather than 3, but his quotes are 0, 1, and 2. And so these will keep track of every time you click the button, they will be changed. So it'll go to the next item in the array. And then each of these functions are basically the same. It goes and the button calls this when calls this method and runs this code when it's pressed. So it just outputs this is the name of the array, this is the current item in the array that it is looking at, and then if you've printed out all of the different quotes in the array, then it will go ahead and it'll take a look at the length of that array and reset it. It's -1 because it's 0 based, and then if you're not at the end of the array, if you haven't printed everything else out, then you'll just decrement the count by 1. So anyways, all of these functions are the same, and this is where they're called. This is just, I created a button, I put the image over top of the button, and this command keyword here, this command parameter is how the function is called. So it just calls the action Luke code that I wrote right there. It calls this code, and then it just runs it every time the button is pressed. And then grid is just so that the buttons are nicely formatted in the 2x6 array that you saw when the program gets run. And then the padding so that there's space in between all the buttons and everything. So, and this right here is where you've got the paths to the file, to the images, and it's stored in a variable, and then the variable is how the button is able to figure out where the pictures are. So it's pretty easy. Just to show a message box, just to show a window, it's literally just one line right here, and that's what shows at the very beginning of the program. Welcome to my program. For other languages, it takes multiple lines and it's more complicated. Like if you were to make a WinForm, a C# WinForm application, like I did at my previous co-op, we had a whole window template that you would have to use, and it's multiple functions that are already predefined, and it's doable, and it's relatively easy. But with Python, it's literally just one line, so it's nice and simple. So you can go ahead and get started. And then this is what causes the window to open up, main loop, and it just sits there and keeps the window open until you close it. So it's pretty. Yeah, I'll put this up on GitHub so people can download it and mess around with it if they want. There's also this example program that Joey let me borrow. It's on his GitHub as well, where if you run it, it scrapes wiki pages.
Yeah.
So you can just get all of the data.
What a stupid program.
All the data.
But there are it's really easy to make web scraping programs. Do it legally. Only scrape legally. But
only a bald person would make this program.
I'm trying to get my computer to learn how to love. Thank you very much. Okay.
Oh my God.
Starring Joey Kilgore.
Hey Joey, out of curiosity, what library did you use to do the scraping?
So this uses the Wikipedia API. It's actually really easy to use. The commands are self-explanatory, and it's pretty procedural. And by procedural, I mean you just run every line, kind of just runs itself, and you can start scraping things.
Yeah.
For those that don't know, web scraping just means you take a web page and you take all the content from it and kind of download it, and so you can save it yourself.
Yeah, so you can do that. One of the applications that we used web scraping for, or what one of the teams that went from our campus to the Highland Hackathon, was they downloaded YouTube videos and they parsed them into their individual frames. So all the individual picture frames of the YouTube video, so that they could get thousands and thousands and thousands of images. It just ended up being gigabytes of data on their computer, so that they could train machine learning algorithms, because you need lots and lots and lots of data in order to train machine learning algorithms. So and with Python, it was just one file. You could just do it in one file, really quick and easy, much faster and easier than if you were to try to do it with C# or anything. There's just libraries of pre-written code that you can utilize to do things like that. We've also written, I know teams have also written Discord bots. They wrote Brentley bot back in the day, where it was just a Discord bot that would spit out Professor Nolan quotes. He would go get memes on the internet. So there's a lot of different applications that you can use this for. A lot of them are fun, and it's a great way to learn how to program. And I'm trying to get my 14-year-old brother to start learning as well, because I was just showing him yesterday some of the system.out, or the printing commands printing to the console, where you can interact and type in words into the console and get a response. And he was like, I don't know why I like this so much, but I want to keep on doing this. And so I was like, okay, that's cool. So that's the little program that I wrote. And we'll switch back to the slides. If you want to get started using Python, you just need to download Python 3. There used to be like issues because some code would be written in Python 2 and some would be written in Python 3, but just download Python 3, and nobody uses Python 2 anymore. This is the link to the IDE, and I'll send these slides in the ACM channel afterwards. I'll link to them so that you can head to them and click all the links. And then this is just all of my works cited stuff. So there's resources that you can go into here for if you want more information, and just where I got my general information from. And the last thing was, we have a Minecraft server for all the freshmen. If you would like to join, this is the IP address. You'll have to, it's whitelist only, so you'll have to send your username in the Discord just at me, and we will add you. With that, I'm going to open up for questions. Does anybody have any other questions?
Do you have the Derek Bana's Python in one video linked?
I do not.
Oh, buddy, what are you doing?
Isn't that the
You're
4-hour long one?
It might be.
I
It's
think
beautiful.
Let's pull this up.
Nobody's gonna watch that.
Derek Bana's is
There we go.
like the programming wizard.
Here we go. We'll go ahead and we'll put this
There you
in.
go. Python. You're gonna learn the whole thing in one video.
There you go.
Easy.
And it's only an hour and 51 minutes.
Oh, boom! Put that 2 times speed. You're done in an hour.
Yeah, you'll just be a Python expert. It's gonna be great. And look at that! Look at that! He even is using PyCharm, just like yep, perfect. Look at that beautiful logo. It's fantastic. All right.
I recommend VS Code.
You can also do that.
VS Code is
Same.
much better.
Okay.
I recommend VS Code.
Oh.
So I already have PyCharm, and so when you download PyCharm, right, it already has all the libraries, correct? Or you have to download them separately?
I had to download Python separately.
Okay.
And when I did that, because I downloaded PyCharm first and then Python second, it did not know where the interpreter was, which you can change here. This down here at the bottom, you can click Add Interpreter, and then you go to the path where you installed Python. It should automatically pop up. It does by default. Mine, it tried to go to the Windows App Store location and look for it.
Okay.
I ignored that and went to where I installed it from the Python website. And then you
Yeah,
click
because
OK.
I downloaded Python ages ago, and I think I have the libraries on there. I just
Okay.
forget if they if the libraries download separately or if it comes with it. I'll check again. I'm pretty sure it comes.
Yeah, when you download Python, there's a lot of standard libraries that come with it, like tkinter, for example. It comes with it.
Yeah.
You show them how to pip install.
Oh yeah.
The most powerful of all.
Yeah.
commands.
So you can go to the
Literally
Python
pip
console.
install.
You could do pip install, and then, for example, if you want to do the wiki thing, you can just do the wikipedia.api. The funny thing with this one is that when you do the pip install, there's a dash between Wikipedia and API, or not, or I can't spell,
Pip
or
3, I think.
pip 3.
Yeah. Because you're on Python 3. What?
Why are you still sad? Well, you're supposed to just be able to do that. Should it be?
Yeah, the install.
Did I spell it wrong?
Doesn't look like you did.
I don't think you had to do pip 3.
Was it?
I didn't
is
have to
pip,
before.
I didn't think pip was able to execute through like the actual Python console. I thought it had to be done through
It might
like
be
terminal.
That's
Yeah.
I know VS Code you can, because VS Code's awesome.
VS Code is supreme.
Is pip included with Python 3?
Yes.
I think you might have to.
Yeah.
It might be included.
Oh,
Like,
well,
you have to do something.
yes. So when you go to install, like, when you go to install Python, I think you have to check the box that tells it to include pip when you download it.
Yeah, I think it says include pip and wheel.
Oh, there we go. Oh, it still crashed. That's cool.
Well, that's the command, guys, is pip install.
Oh, there we go. Now it worked. Okay.
Yeah.
Finally. Okay, you got to do it from terminal, not the Python console. But yeah, it works.
And then you can get any package you want.
Oh yeah.
It's awesome.
You can look up things like 24 Python packages that everybody needs. Arrow. There's one called Pandas.
Yeah, pandas.
Yeah, that's like a database parsing one, or you get to do stuff with databases with that one. No, I'm not subscribing.
Hold on, I'll be right back.
Okay. All right, that's all I got. Do you want to take away with the website, Sam?
No, you can do it.
Who, me?
I have faith in you.
Wow. Have
You
no
got
faith.
this. We all believe in you.
Yeah.
I know so much less about the website than Sam does.
Ronnie, that's a good ticket, by the way.
Did you make a ticket?
Oh, Ronnie made one. I'm like, oh yeah, we do need that. I
Can
put
you guys
like
still
270 particles in there.
I can't figure out how to work the branches. I've been sitting here this whole call struggling to find out how to push to the branch.
Oh, we need to have a Git talk.
Yeah.
Mm-mm.
You want actually, Joe? You want to do that next meeting?
Ooh. Yeah.
Thank you.
Oh, that might be good for the freshmen. Do you mind if we push your Fortran talk back a little bit, Kyle? And do it.
I don't care.
Okay.
No, we need
Fortran's
Fortran.
trash.
We could do Git and Fortran next meeting.
No,
Okay.
that's
Can you do Git in a half hour?
Yeah.
Yes.
Git from.
No.
I think we still have the recording too from when you went over Git the last time. I'll have to look. Yes.
Well, show the website first.
Okay. Let's see. So Heroku is the oh boy, is the website that we use to host the database, or to host the website actually. It's gonna be just a second.
Josh, share your password. No.
I'm surprised you guys can still see my screen. I switched desktops.
Oh, yeah, I can totally still see your screen. Ooh.
Which of my 3 monitors?
Same.
Subtle flex.
They
Yeah,
were all
because
pulled out of the
he
trash.
doesn't
Don't
have
worry.
He doesn't have a vertical, so not really that much of a flex.
That's
Ooh.
true. I could turn this one vertical though that I've got over here. Okay.
Double vert was the
I
only
sent
way
you
to
the
go.
link, Josh.
What?
I sent you the link.
Oh, thank you. Alright. Here we go. Alright, so this is the website. This is what we got so far. There is a lot of particles.
The
There are so
particles.
many particles.
What?
There's like 200 of them.
Oh my
There's
gosh.
so many.
I wanted to test to see if it worked first, and then I forgot to tone it down when it got merged.
I like them.
This
Leave them there.
Well, look at this. It's still. But look at this. It freaking out
Yeah.
like right now.
Like
what's
the
going?
FPS on this screen is insane.
Oh my goodness.
Did you use any specific libraries for those particle effects?
Definitely, I didn't create that.
Yeah, it's Particles.js. You can look it up on Google.
Yeah, man. Google it.
Just Google
Just
it.
generic.
So it's cool. Like when you scroll down, the box follows which page you're at. It's really cool. You can jump around. The about us. We should probably. We've got like our own little like. Who? If you ever forget who's like. helping out with ACM right now. It's down here. But yeah, we'll have this sign-in page here. Right now, it doesn't go to a back end like to an account page, but this is pretty cool. It flips around like that for sign in and sign up. It'll send like an email notification when you sign up to an admin so that they can approve your account. So
All
that's-
admins.
All admins. But yeah, it's
Point of technicality.
yeah. I like the color
this is
scheme and
just a
everything.
s-
It's
yeah,
this is
this
the
is a
bare
start right
bones.
now.
Yeah.
Yeah.
Do you want to talk a little bit about some of our future ideas for it, Sam?
Not really.
Okay, I'll talk about them. Okay. Sam is our chief software officer, if you didn't know. He's the guy who heads up the website and is the go-to guy if you have questions on web dev. And I can help out too with database stuff because that was one of my co-ops. But one of the ideas that we had was to try to integrate hardware with this website. So for example, to integrate a temperature sensor that we could go to and a page that we could go to that would display what the temperature is at UPRC at the school at any given time whenever you log on. So it would be live updated. So that would be kind of cool because you have to use WebSockets for that, did you say? Sam?
Yes.
Yeah,
You do?
WebSockets are awesome.
Yeah. So that's one of the things. Another idea that we had was a lot of these things that you see, like the buttons. I believe the buttons are all custom made, right? We made them ourselves.
The buttons right now use Bootstrap.
They use Bootstrap.
which-
Okay.
I'm pretty sure the sign-in button is from scratch, right?
Sign in is? I don't think so.
I thought I
Usually-
remember. Anyway.
But one of the things we were going to do is make a custom calendar where we could post ACM events that are going to be happening, things going on at the school. That way it's in one place so that everybody can access it. And it would just be a good resource to have. And it would be cool to just build your own calendar from scratch. And
yeah,
then,
you're right, Ronnie. It is from scratch.
so the buttons from scratch, okay. So yeah, we've got our own library where we put components like this, and we can put them in different locations as well. What other things were we thinking? Go ahead.
One comment. I don't know if you're legally allowed to put a fickle ACM website. Or it
Okay.
says official. But I don't think this is the official ACM website.
This
It
is
might
not.
be,
This is not the. This is the official UPRC
Chair,
chapter. Yeah, we gotta. We, gotta
We
change
need to
this.
fix that.
Don't get us in trouble before we get this thing going.
image in the background. Do you have rights to that? Come on.
Yeah, I don't know.
Oh,
That's
nay, it is on Google.
that's not how it works.
Good enough for me. That's good enough for me.
Goodness. I know there are places where Toledo has like free open source like logos and stuff that we can use too.
Yeah.
Yeah,
So
they have it all written out. No, ask for forgiveness, not permission.
Amen.
I don't know what you're talking about. We took this image ourselves.
Oh, I see what you're doing.
Okay.
Plausible deniability. I like it.
oh my gosh. Well, I don't think we'll get away with that because the sign's broken right now.
That's a good point.
Oh yeah, that's a good point.
Yeah,
But we didn't tell you when we took it.
that is true. Okay. Well, besides all of the legal stuff we have to take care of.
Well, don't look at the other picture then. 'Cause
Oh,
that's
dear.
not ours either.
Oh dear. Yeah, we can't really get out. Oh no, that's outside. Okay, I thought this was the roof, but
Time to get out the camera phones.
yeah, we could take our own
No one
pictures.
needs to know.
Yes, I agree. But we'll change the UPRC chapter.
And also, we're gonna have a place I think where you can put your own personal GitHub projects that you want to share with other people. Just links to them. So there'll be like individual login page for users where you can do that, and we have a bunch of ideas. And if you guys have any ideas as well, we're open to those. It's a group project. There are small things to work on for beginners. There's large things to work on for people who have more experience, and there's a ton of help along the way. So if you're interested in helping out, we have coding sessions where we work on it most of the time it's every other week. They're announced in the Discord. You have anything else, Sam? Is there anything else that we were supposed to go over?
If you want to work on it, just let me know and I'll add you to the GitHub repos.
Right. But let me check this. I think that's everything that I had. Luke, you're a robot.
I understood none
Not
of that.
Shane.
What?
Sorry.
We don't know what you said, Luke.
I think he might have died.
I think he died.
I think he's dead.
Who, me?
No,
No.
Luke.
Should we call the ambulance?
Now.
All right. So, is there any
Wait,
questions?
Wait, can you hear me now?
Yeah.
There you go. Much
Okay.
better.
Cool.
Are there any questions that you guys have, specifically the freshmen? If you want to let us know that you want to work on the website now, or if you have any questions, comments about ACM, we can do that now. If you have anything else, I don't have anything else.
Nice presentation. the parts that I did here.
Oh, thank you. Did dinner turn out well?
Yeah, so there's some good Parmesan chicken.
Ooh, nice.
Or the Parmesan crusted chicken, you know, that's on the mayonnaise container.
Oh, yeah. Very nice. So what things are you guys excited for with the program?
Coding.
Coding? You're excited for coding? Are you guys in
Experience?
how many of you guys are in 1030 right now?
I am.
I am.
All of them are.
I am. I think we're all required to, right?
Yeah. Mhm.
Yeah.
Yeah.
Okay. Now
I am in Digital Logic also.
you're in DLD? Oh, that's a fun class. You're going to like that.
Wait, what? Wait, you're in DLD?
Is that what you call Digital Logic? Oh yeah, that's what it is.
Yeah.
I can. Yeah.
What with Professor Nolan? What time?
You mean the lab?
I mean, like, is it
Lab.
the Monday, Wednesday?
Yes.
There's usually
Or
only one
hawkish.
DLD class.
Yeah.
I don't know, Sam. Come on, Sam. Oh, we're in the same class. That's all I'm saying, Sam.
All right, that's all I got. If you guys want to stick around in the channel afterwards and chat, we can. But for now, the meeting's adjourned. Thank you all for coming, and we hope to see you at the next couple of meetings. Keep on coming.
Party.
All right.
Okay, now we can talk about like fun stuff finally.
Now I can stop the recording.
Yeah.
Oh, the recording for this will be up on YouTube as well.
There are. You can find